Problem 1. Which of these numbers is the smallest? And then we're presented with 5 options. So fairly straightforward problem. We know exactly what the question is asking. And we have 5 options, one of which has to be the smallest number out of the 5. And another thing that I see immediately is that all of these are fractions. So I suppose that makes it kind of easier to compare them to each other, right? As opposed to if there were like square roots or exponents or something like that. That would be a little bit harder. So I'm going to just go through all the different options and see if there is one number that is maybe the easiest number to deal with. So let's take a look here. So we have first one is 5 over 9. You can't really simplify that anymore, so I'm just going to leave that for now. 15 over 28. That is something that I see immediately that we could simplify further. But let's keep going. 26 over 45, all right. And then there's a 7 over 14. And the last one, we have 13 over 23. So which one do you think out of these is probably the easiest one to deal with? Well, I don't know about you, but for me, it's definitely this one, 7 over 14, because I can immediately see that 7 over 14 is, of course, the same as 7 over 2 times 7, right? 14 is just double of 7, which means that I can cancel these two out, which means that I am left with 1/2. Now, that is definitely my favorite number out of all of these. So I'm going to start with that one. Now, I know that out of all these 5 options, there's one number that is the smallest out of all of these. So there's no number where the two numbers are equal, right? So what if we were to choose one of these numbers and compare it to all the other numbers one by one, and for each time you're going to compare it, is this new number compared to this number that we're dealing with smaller or bigger? And then based on that, we take away that and then say, okay, it's bigger, so definitely can't be that, and then we keep on going. Let's try that. So let me pick this number as kind of my, you can say, a pivot number or a number or a comparison number rather. So let me start with this one. All right, so if I have 5 over 9, okay, well, 5 over 9, and then comparing that versus, let's say, 1 over 2. Well, I can immediately see that in order for me to more easily compare these two numbers, I can turn this number into a different kind of fraction where I multiply both the numerator and the denominator by some number. Let's try that now. So what if it was, this multiplied by 5, let's say, and this multiplied by 5 as well? Then I would get 5 over 9 versus 5 over 2 times 5, that's 10. Well, now I can compare them, right? Because this number right here is 5 divided by 9, and then this number is 5 divided by 10, which is a higher number than the 9, right? So then from that, I know that this number must be bigger than this number, which means that this number now is not in the competition anymore. We can discard that. All right, let's keep going. So now we have, let's go with this one. So now we have 15 over 28 versus, I'm still going to use this number, right? But before I just write it out like this, I'm going to already kind of multiply it by something first. And what does it make sense to turn this into to more kind of accurately or more, compare it in a better way? So what I'm going to do again is that I'm going to make one of these numbers be the same one as one of these. So what can I multiply 1 by to get to 15? Well, I can multiply it by 15, so let's do that. 15 up here over 2 times 15, that's 30. Aha, I run into the same thing. Same numbers, both of these are the same. But these two are different, and whichever number is smaller means that the entire fraction obviously is going to be resulting in a higher number, larger number than this one. So again, this number also is out of the competition. Let's keep going. Let's do this one, 26 over 45. Again, versus this one. What can I do here? So if I were to turn the above one again into a 26, what would that one be? So now that would be twice of 26, which is going to be 52. 52. And that, of course, again means that this one has to be a larger number than this one. So again, this one is also out of it. And we only have one option left. Let's do that one. 13 over 23 versus 13. 13 times 2, that's 26. And once again, we have a number here which is larger. The denominator is larger, which means that overall this number has to be smaller than this one. And we compared it to every single thing, which means that by process of elimination, it has to be D.